Stereo systems and boomboxes from the 80s and 90s are famous for having an overabundance of buttons, dials, switches, and knobs, and may look intimidating at first, but generally through experimentation and experience you can figure out what they do, except for one. It's labeled using ambiguous or inscrutable terminology, and the vast majority of the time changing its position has no discernible effect. Or you may have not even noticed it because it's often put on the side or back of the unit, or is combined with multiple other functions on the same button or switch. It doesn't help that manufacturers couldn't agree on what to call it. Names for it include beat cut, beat cancel, beat proof, often abbreviated to BP, or simply just beat. Other names for it include ISS, OSC, BFC, and bias mode. And if they are labeled at all, the positions are marked using meaningless numbers, letters, or dots. This paint-splattered GE boombox from 1992 is the only one I have which gives any indication as to the purpose of this button. But that still doesn't tell you why you'd want to cut the beat when listening to records in the morning.
Papa loves mambo, Mama loves mambo. Look at...
Oops.
And sometimes the owner's manual, if you can even find one for a 30-year-old product, isn't of much help either. The one for my JVC PCW222 portable component system says beat cut switch. When recording an AM or SW broadcast, beats may be produced which are not heard when listening to the broadcast. In such case, set this so that the beats are eliminated. At least now we know it refers to recording from AM radio, not vinyl before noon. But what's the deal with producing beats? AM radio is better known for Rush Limbaugh than Grandmaster Flash. Well, as I mentioned, this is a case of ambiguous terminology. The beat that the switch eliminates is not the beat of the music. It is referring to a beat tone or beat frequency, like the warbling effect you hear when you play two notes next to each other on a piano. Those strange noises are examples of beat tones. A similar kind of beat frequency may be generated when you have an AM radio tuner and a tape recorder in the same enclosure.
Elaborating, so I will elaborate extensively tonight. Now,
in order to have good quality, a cassette recorder needs to add a bias signal to the tape when recording. I'll let VH1's Bobby Rivers give a simple explanation of how it works.
Look out now, we're going to get a little technical. Ever wonder why some tapes are called high bias? Here's the best explanation I've ever heard. Bias is a super high frequency signal that acts like MSG in Chinese food. You add just the right amount and the recording sounds delicious. Add too much or too little and the music is never as tasty as it should be. Listen to this recording of Angel Dean and the Zephyrs made with the right amount of bias.
That bias signal is generated by an oscillator coil, such as the one you can see here inside a cassette deck. That doesn't cause any problems with radio reception when the cassette deck is in its own shielded metal box, but if I remove the cassette deck's cover and turn on that radio and put it close to that oscillator coil, you can hear a whistle. And if I stop recording, the whistle goes away. So that poses a challenge when you're designing something like this stereo system, which has a radio tuner and a cassette recorder in the same enclosure. If I take it apart and look at the circuit board, here is that bias oscillator, And down here is the built-in AM radio antenna. And you can see they tried to mitigate that interference by putting them at extreme opposite ends of the circuit board. But when you're designing something smaller like a boombox, or especially a handheld cassette recorder with a built-in radio tuner, you don't have that luxury of keeping the bias oscillator coil and the AM radio tuner apart from each other to eliminate that chance of interference. So with something this small, when you start recording an AM radio signal, you may get that kind of whistle in the audio. So that's why they include that oscillator switch, in this case, otherwise known as a beat cut switch, or those other names I mentioned earlier. If you move that switch, you can hear there's no more whistle. If I change it back, we get the whistle. That interference does not happen on all AM radio frequencies, just ones that happen to be harmonics of the frequency used by the bias oscillator and the cassette recorder. It also does not happen on FM because FM uses much higher frequencies than AM, and frequency modulation is less prone to interference than amplitude modulation. However, this beat frequency interference can happen on shortwave and longwave as well, not just the band that some parts of the world refer to as AM, which is actually the medium wave band. So what the beat cut switch does is it slightly shifts the frequency of the bias oscillator and the cassette recorder. Not enough to negatively affect the quality of the recording it makes, but hopefully just enough to shift it away from the frequency of the radio signal you're trying to record. And that's why they give you several different positions, because it may shift it to a frequency that happens to collide with another radio signal, so you get multiple choices so that no matter what frequency you're trying to receive, one of these choices should be able to get rid of that beat frequency noise. Here I'll give a sample of its effect on my Sanyo stereo system, which confusingly labels the beat cut switch bias mode. You may have noticed this button labeled bias mode, but that's a misnomer. It has nothing to do with whether you're recording on normal or high bias tape. As explained in the manual, it says when recording from an AM station, interference in the form of a beat, howling, or whistling may sometimes appear. In this case, simply set this switch to the other position.
The other part, Mary Louise, when you're talking about the simplicity.
For example, I'm recording from a station on 8:20 AM, and maybe you can hear that annoying whistle in the background. But if I push this button, the whistle disappears. Conversely, there are some other frequencies where you get a whine with the button pushed in, but releasing it gets rid of the whine. There are several ways to avoid the need for a beat cut switch. One is to use DC bias recording, which does not require a bias oscillator and thus eliminates the problem.
Many inexpensive portable tape recorders use DC bias because it simplifies the circuitry and reduces battery consumption compared to AC bias. However, as I'm sure you can hear, it also produces recordings that are more noisy and shrill sounding than AC bias, making it unsuitable for use in high-quality tape recorders.
FM 96.7.
And especially beginning in the 1990s, many stereo systems opted to use an external AM loop antenna like this, which solves the problem by putting the AM antenna completely outside of the cabinet where the cassette recorder circuitry is. Plus you can rotate it to get the best reception. And sometimes, even when a system does have a beat cut switch, it's not actually needed, such as on this 1992 GE boombox, which as you can see has a rather large cabinet, and I think it has enough physical distance between the cassette recorder circuitry and the radio tuner circuitry that beat frequency interference does not happen, but yet they included a beat cut function anyway. I think this is because it must share the same circuitry with smaller boomboxes where that interference would be a problem, and it was simply cheaper to reuse the same circuitry on this larger model than to modify it, because this one does not suffer from that problem. So it does have a beat cut switch, but it doesn't really have any effect. I actually have a real-world sample of how a recording can be impaired by not having the beat cut switch in the correct position. This was a recording I made back in January 1998 of a new radio station that just went on the air. Their first day on the air was January 5th, 1998. I missed their sign-on, but I did get a recording of them at night that day, so I wanted to set my timer on my stereo system to begin recording the next morning, January 6th, at 6 a.m. when they signed on the air. I was using a Seiko stereo system just like this, which had a dual cassette deck, a radio tuner, and a timer. But if we zoom in on this photo, we can see it has a button labeled OSC, which, as we know, is a beat cut switch. And I neglected to have that in the correct position when I was recording this radio station, causing a constant whine in the audio. So I'll give you a sample of what that sounded like. It starts with Jack Ellery, the morning show host on WJHR, talking about how foggy it was that morning.
I was following the guy ahead of me, and that's what you have to do, is just follow the guy. And I followed him and followed him and followed him for about 15 miles, and all of a sudden the sucker slammed on his brakes, came to a screeching stop. I leaped out and said, "What are you doing?" He said, "This is my driveway." Holy crow, and all that sort of stuff. All right, we are WJHR. We're at 1040 on the dial. We are broadcasting from Flemington, New Jersey, covering a good deal of the state of New Jersey.
There is at least one new product which you can still buy today which has a beat cut function. It's the Sony CFD S70 CD cassette boombox. Sony calls it ISS, which stands for Interference Suppression Switch. If I turn it on, tune to a weak AM signal, and put in a tape and start recording it, maybe you can hear a whine, but if I push the play mode button and change it from ISS1 to ISS2, the whine disappears. And you actually get 3 different settings here. But clearly on this frequency, ISS1 does cause that beat noise, but changing it gets rid of it. I know this topic may be of diminishing relevance because AM radio is unlikely to see the same revival of interest as cassette tapes have experienced in recent years, and in some parts of the world, AM radio is basically already extinct, even though that is definitely not the case here in the US. But I know many people have been puzzled by seeing a beat cut switch, or whatever it's called on their particular piece of equipment, and they've wondered what its purpose is and how it works. And, well, now you know.